Okay, so here's part two. So let's see what we have next. So right here, I guess there were some questions about how sometimes you get kind of these funky answers with the where your denominator might be something you're not familiar with for the unit circle. And so what's going on with these is these are pretty identical questions. What's going on here is we're making adjustments on the angle that's being evaluated, so we have to adjust our intervals in that same way. And this is just a way of approaching this. There's other ways of doing this problem, but this is probably the most popular way to kind of keep things organized. And so what you do is you expand, in this case, sometimes you condense, but in this case, we're expanding the interval. We're going to double it. And so what you do is you just go ahead and find those values on the unit circle like you normally would, where does sine equal 1. And so if you remember on the unit circle, it goes 0, 1, 0, -1, talking about sine. And so right here it equals my y value, my sine value will be 1 at pi over 2, right? But and then we expanded the interval to where we can go around multiple times, though. So if you were to add 2 pi to this, that would cause us to do another rotation, and you'd still land right here, right? So if you add 2 pi to this, you have to get a common denominator. So we end up with pi over 2 plus 4 pi over 2, which then gives us 5 pi over 2. And so those are the two angles that we find that are within our adjusted interval right there. But the thing is that you got to look back at the original function, and it's not actually just theta, it's 2 theta. And so you have to basically kind of undo the adjustments that you made to that interval right there. So what we're going to do is divide those results by 2. And dividing by 2 is the same thing as multiplying by 1/2, right? So the denominators got doubled, and that's how we ended up with those angles right there. So that when you plug it in, when you take this and plug it in here, it's going to get multiplied by 2, which then goes and knocks, or would turn it into pi over 2, which we know pi over 2 works. And then same thing with 5 pi over 4. When you plug that in, that by the way, that is within my original parameters. And then when I plug it in, that would reduce my denominator down to a 2, that 5 pi over 2, which once again, if you were to take the sine of that, it would equal 1. Okay, so looking at number 8, it's basically the same thing. You double it and you find where cosine is equal to square root of 3 over 2 on the unit circle, and then you just have to go around the unit circle multiple times, or well, you can go around one extra time because we expanded that parameter, and then you have to divide it back out. And so that's why we ended up with 23 pi over 12. I know you mentioned that one in your email. And so that's just kind of what's taking place here. Is really what you're doing is it's this angle right here plus 2 pi. If you add 2 pi to this, which would be the same thing as 12 pi over 6, right? That's the same thing as 2 pi. And so if you add this to this right here, that gets you to 23 pi over 6. But that would be true if that 2 wasn't there, but the 2 is there. So we have to make that adjustment, basically undoing the adjustment that we made to the parameters. So we divide by 2, and that's where that value comes from right here. All right, let's see. What else do we have here? Okay, this one was actually completed. And so I think I'm just going to kind of leave this one alone. Not that it, yeah, there was a lot to it. You had to factor it, and then you take each one, and you were dealing with the case where you had to triple your parameter. So you were actually looking at from 0 to 6 pi. And so anyways, if you have questions about number 9, let me know. But The video did go all the way through it, so they should all be there. So let's see what else we have here. Number 10, this one isn't too bad. There are a lot of solutions on this one, so we can go ahead and take a deeper dive and look at this one. And so we're looking at where is tangent equal to 1 or negative 1, and we have quite a bit. You're gonna do 3 rotations and find that. So we're just finding coterminal angles where this occurs. So within 1 rotation, there's actually going to be 4 times that this occurs. So see, it occurs here because your x and y are the same, and so that ratio is 1, right? And so that would be at pi over 4. Then it happens again right over here, which would be at 3 pi over 4, and then it happens again right here, which would be at 5 pi over 4. And so you're getting the here you're getting -1, here you get +1. So I'm actually listing them for both of these currently. And then our last one right here would be at 7 pi over 4. But the thing is, if I keep rotating and going around, so remember this is at 2 pi right here, but basically you could add 2 pi to this and it would just keep going. And so just remember 2 pi would be equivalent to 8 pi over over 4. Fix that, 4. And so what you're basically going to do is if you just keep adding 8 to your numerator, that causes you to go around a whole rotation. So if I were to, and remember I can go around to 6 pi, which 1 revolution's 2 pi, a second revolution would be 4 pi, and a third revolution would be 6 pi. And so what that allows me to do is I can add 8 pi over 4 to this twice. So when I add it once, that'll take me to 9 pi over 4. Then if I do it one more time, then that would take me to 17 pi over 4. And so see, the first one took me here. And the second one, when I added that 8 pi over 4, it took me around again. And then I did it one more time and it came around right there. Now I don't want to do it again because if I do, then I surpass my 3 rotations. So I did 1 rotation, 2 rotation, a little more than 2 rotations. And so see, if I added another 2 pi, I would surpass the 3 rotations that I'm limited to. And so anyways, that's going to be true for the other 3 spots. So here are 3 of my solutions, and then I'll get 3 more here. So when I add 8 pi over 4, let's see, what does that give me? 11 pi over 4. Then we do it again, that will give me 19 pi over 4, and so on. And then same thing with the ones down here. So I'll let you finish this off, but you'll do the same thing down here. Just basically add 8 to the numerator, and that causes another revolution, another rotation. And let me see, do I have any? I think we have one left to maybe discuss. Let's see this one. Okay, so let's see what we have going on here. So we multiply by cosine, and then here we go. We got to the factoring, and we should have 3 exact solutions. Okay, so this one's back to kind of being the ones where we do not have to adjust the intervals because all my angles are just x, not 2x or 1/2 x or anything like that. So this one should be ready to go. It shouldn't be too bad. So let's see. We're going to take each one of these, set this equal to 0, and solve. So we take this. So let's see. 2 cosine of x plus 1 equals 0. So we're going to subtract by 1 and then divide by 2. So we're looking at when is cosine equal to -1/2. And once again, we're only looking at 1 rotation of the unit circle, and I'll draw us a picture in just a second. And so there should be 2 spots that occurs. Then we take the other one, set that equal to 0, and solve. So we add 1 to both sides. And so let's see, we end up with cosine of x equals 1. And so we just have to figure out where those spots are. And so let's see, I'm going to go ahead and draw the unit circle here. So let's see, cosine would actually be equal to 1 right here at 0 and at 2 pi. At 2 pi. Now, 2 pi is not part of my parameters. My parameters are from 0 to 2 pi, but not including 2 pi. But we get to include 0. So 0 is going to be one of my answers right there, because cosine equals 1 at 0. And then cosine, where does it equal negative 1/2? So let's see, that's my x value, right? Cosine correlates with my x value, negative 1/2. And so that would be this angle right here, because that's what this x value right here would be. It would be negative 1/2. And then that would also correlate with this angle right here. Now, it's not perfect, but let's see, there we go. So those are my two angles that I need right there. So I want this one right here, and then I want the one coming all the way around right here. And so if you were to look at your unit circle, let's see, I believe that would be at, this one would be 2 pi over 3, and this one would be 4 pi. Oh wait, hold on, let me double check that, make sure I'm doing this right. Yeah, I believe that is right. So 4 pi over 3. And so those are going to be my 3 solutions for this. So I hope that kind of clarifies any issues you were having with this, but let me know if there's anything else you kind of want me to go over. I'll be more than happy to.